Welcome back, ladies and gentlemen. We're looking at sections 1.8 and 1.9 here. It's going to be function combinations and inverses. I think we can handle these two together because we're not going to do every bit of each of these sections, but they are also big Algebra 2 reviewish sort of thing, so I think we can power through these things together. Okay, we're going to perform operations on functions, which is what you see here on this slide, find compositions of functions, and determine inverses of functions. Well, operations, well, of course, add, subtract, multiply, and divide. So if I'm doing f plus g of x, so, well, all that really means is if I've got two functions, all I'm really doing is adding them together. So whatever your two functions are, work out whatever f of x plus g of x is and call it a day. Similarly, if I've got the subtraction, all that means I want to do is subtract my two functions. Again, simplify and see what you get. Multiplication, no shocker right there. We're just going to multiply the two expressions together. And if we're dividing, well, again, I know this is breaking all kinds of misconceptions you might have had about life in general on this planet, but if you're dividing right there, all you're doing is dividing the two. Just one little glitch right here we got to watch out for, but g of x cannot equal to, well, since on the bottom, and what we know about domain, we know that g of x cannot equal 0. But if you're doing the operations, that's all you really need to do. Okay, I'm going to do a couple quick examples of this kind of thing. Alright, so here's our example. So using f of x is 2x squared plus 5x, and g of x is 6x minus 7. I want to do f minus g of x. So again, all that means I want to do is do f of x minus g of x. And so again, I'm basically going to substitute those two expressions into the appropriate spots. So I've got 2x squared plus 5x. And then now minus, and again, please use parentheses here. We have sign issues if we don't. Subtracting that. So then a step that some of you may not need to do is now distributing this negative sign, so we get a negative 6x, but now a plus 7, and that's the sign that people are going to mess up on. And combining any sort of like terms we have gives us 2x squared, now a minus 1x, and then a plus 7. So there you go. That's what you get by doing f minus g of x in this scenario. Okay, using the same two functions, I want to do f over g, or f divided by g of x, and again, all that means is do, well, f of x divided by g of x. So I'm going to skip right in that step and just cut to the chase here. I've got 2x squared plus 5x. That's going to be my numerator now, and then my denominator will be the other function of 6x minus 7. And sometimes the hardest thing in math is to not do something. Well, if we're looking at this expression right here, it looks very tempting to try to factor something or cancel something, but try as you might, you can't do anything, like legally, I suppose, mathematically, without getting crazy about stuff. So realistically, here, simply writing them on top of each other leaves you stuck without being able to simplify any further. So simple enough, there's your answer without any sort of work. Okay, moving on to compositions now. Composition is just a function of a function, and the notation is going to look like this. It looks like we're trying to say the word fog or something like that, but this is an f, it's a tiny little circle, and then we have a g. So that's, well, let's pronounce it properly and say it properly, but this notation right here means f of g of x, and well, there it goes. It's pronounced just as how I said it. It's pronounced f, and I'm going to leave a big space there, of g of x. And again, basically whenever you hit that parenthesis, you say the word of. So f of g of x, and those parentheses are just kind of closing just because that's what you're supposed to do when you open one, you close them. So anyway, there it is, but again, that should be big time review, so I hopefully didn't shock anybody with that. Alrighty, so let's put this composition stuff into action a little bit here. So, well, if I'm going to put two functions together, I need two functions, and there we are. I got an f of x and a g of x here. Okay, so if I want to do the composition first, we'll get to that f of g of 6 in a minute. But if I want to do f of g of x, okay, again, all that really means is I want f of g of x. Okay, so I want f of some other function. That function happens to be this guy here, the 2x minus 9. Okay, and from that difference quotient stuff we've been doing, okay, we've been plugging an x plus h into other functions, so this hopefully shouldn't be too much of a shock for us to do. Okay, basically f wants us to take something or other, square it, and then add 5 to the result. In this case, that something or other is that 2x minus 9. There we go. Okay, so 2x minus 9 quantity squared. Hopefully you can FOIL that out pretty quickly, if else do it in your head. But we got 4x squared, we should have a negative 18x twice, so that's a negative 36x, and negative 9 times negative 9 gives us a positive 81, and then the plus 5 can just kind of come on down. Apparently he's the next contestant on The Price is Right. Okay, combining like terms here, we've got 86, and then I guess what we could do if we really wanted to is throw an f of g of x equals in front of the whole thing, and then this gives us kind of a final answer for that first part. So by doing the composition of f and g in that order, we end up with that quadratic polynomial looking guy there. Alright, and now at this point, if we want to figure out what f of g of 6 is, there's two ways to do it. First of all, doing kind of the more straightforward way, now that we have the function already all written out. Basically, hopefully no shock right there, if I want this to be a 6, instead of the x, I just replace all the x's with 6's. So this guy will equal 4 times 6 squared minus 36 times 6 and plus 86. Okay, well, I know you guys can all do this in your head, so I'll just rattle out real quick. But 6 squared is 36 times 4 is going to be 144, and then 36 times 6 is 216. Technically that's 6 cubed for those of you paying attention at home, and that's 86. And if we put all that stuff together, it actually works out to be a nice simple 14. Alright, so that'd be that. If you're a little more adventurous and kind of want to go back to the start instead of relying on the work we did here, what you could do, thinking of this as a whole separate problem here, if I want to do f of g of 6, okay, a little clever thing that you could pull off is figure out what g of 6 is. Well, g of 6, well, if I put 2 times 6, that's 12 minus 9, so that's really just a 3. So this thing is just a fancy way to say, hey, what's f of 3? And then, well, f of 3, you just plug a 3 into that other thing up there for f. So I'm going to have 3 squared plus 5, and hopefully this won't shock you too badly. 3 squared is 9, plus 5 is 14. So just to show you can get the 14 two different ways depending on basically what you have at your disposal and a few other things, just personal preference kind of issues. But there it is. Alrighty, I'd like to do this the other way around. Do g of f of x. I'm not going to do another one where I have a number involved, but I want to do this one just the other way around, just to show that it's not commutative, and basically that means you can't just change the order and have it work out the same. So if I want to do f of g and then g of f, I can't do one and just say, oh good, same answer for both. But just to prove it here, and I want to do g of f of x. So now I want to do g of the x squared plus 5. And again, all that means is into g, I want to take 2 times something or other minus 9. In this case, that something or other is x squared plus 5. And hopefully very quickly, you'll start realizing that there is no way that this will work out to that other thing that we got a minute ago. 2x squared plus 10 minus 9. So simply 2x squared plus 1. Alright, and again, technically I should throw a g of f of x in front of this guy. And there you go. So totally different answer. Instead of that big long 4x to the second plus yada yada yada, you get something much different. So again, please don't assume that you can reverse the order and still have it come out the exact same way. Alrighty, now again, the whole reason why we have any of this stuff mathematically is because we want to take the real world and turn it into some sort of equations and expressions and stuff that we can manipulate to make predictions about things. And so here we go. So I'm stealing this problem, number 66 off of page 91. I'm paraphrasing a little bit here, but you get the idea hopefully. The weekly cost of producing x units is given by this expression here, so c of x is 60x plus 750, and the number of units produced in t hours is given by x of t equals 50t. And so now find and interpret c of x of t. Well, what I want to do there is exactly what it says, c of x of t. And now, really what I'm looking at is c of x of t is 50t. And again, c wants me to take 60 times something and add 750 onto it. And so again, that something in this case is that 50t, so basically that just slides over here, 50t. So my c of x of t is, well, 60 times 50, that's 30 with a couple extra zeros on it, so that's 3,000. Pretend that's 3,000. T plus 750. Alright, so there's finding. Okay, interpreting is another story. Well, notice how now c is my variable in question on the left, at least kind of my y. Okay, so this is the cost, and then I'm doing some other thing here. And then eventually what I get is this t in this expression. So basically interpreting this, this is the cost, c for cost, and instead of being based on the x like the original one is for the number of units, I kind of had to x play a middleman here to get us to the t, and then t is the hours. So this is cost based on the number of hours that we're producing the various units. So it's kind of almost a law of syllogism sort of thing, and if you remember that from geometry, you know, the kind of linking expressions together, it's kind of what's going on here. So we're using x to get from c to t, and x is the middleman taking us straight to that expression right there. Alright, so there's our interpretation. Okay, that was part A. I don't think I mentioned it previously, but here we go with part B. Okay, now we want to find the amount of time that it must elapse for the cost to increase to 15,000 bucks. Well, again, here's the expression, the equation we just came up with a minute ago. So c of x of t equals this. Well, again, c is the cost. So basically all we do is throw that 15,000 here. So 15,000 equals 3,000 t, etc. Okay, and that's a basic equation. Granted, it's got some pretty nasty big numbers, but you know, just our standard minus 750, and I don't believe I'm writing this for you guys, but there it is. So I've got 14,250 equals 3,000 t, and then dividing off by the 300 gives me t equals 4.75. And again, remember t represents hours, so basically in 4 hours time, our costs end up being 15,000 bucks. Okay, now moving on to inverses, this is technically where section 1.9 starts, so if you're worried about that, that's where we are. Okay, now inverses are two functions that undo each other. So you can do this kind of depending on the simplicity of the function you're looking at, kind of like intuitively. If I've got some function x plus 7, a very simple looking one, and then I want to know its inverse, well, g of x has got to be its inverse. Well, the inverse of adding 7 is, of course, subtracting 7. So boom. Okay, as simple as that. And then if h of x equals 5x, then its inverse is, well, notice here I didn't give you another letter function to deal with, so I'm not just going to make up one out of the blue. I want to use inverse function notation, and so here's what it would be. Okay, the inverse function notation is a little -1 exponent thrown in there between the letter and the of x, if you will. So if h of x equals 5x, then its inverse, denoted by the little -1, is, well, the opposite of multiplying by 5 is, of course, dividing by 5. So it'd be x over 5, or if you're so inclined, you could say 1/5 x, but I don't know, I chose to go that way. Okay, so this is going to seem a little bit basic, but it's one of those things that if you can get the basics down really well, the more advanced stuff comes a little more naturally. So here we go. Okay, overall, an inverse effectively switches the x and the y of a function. So if I've got something as simple as a table giving a bunch of ordered pairs, and I want the inverse of it, well, the inverse of 3, 1 would simply be 1, 3. And then I could do something similar with that. 5, 8 turns into 8, 5, -2, 4 becomes 4, -2, 0, 1 becomes 1, 0, and then 7, 9 becomes 9, 7. Woohoo! Alright, but now, does the original function have an inverse? Okay, that's a question that's going to come up from time to time, is basically, I have my original, hey, it's a nice function, all of my x's lead me to an individual y, but now when I do that inverse, am I still looking at a function? Well, if you look here, I've got a 1 that leads me to a 3, but then I've got a 1 that leads me to a 0. So in this case, the original have an inverse function? No. We do have an inverse, it just happens to be that that inverse is not still a function. Okay, now moving past the kind of intuitive version of this and the kind of basic explanation of it, let's take a different definition. So if f of x and g of x are functions such that the composition either way gives you just the variable x, then those two guys are inverses. And I'll be honest, the book kind of insists that you do this two ways, both ways here. If you have to, if you want to verify that they're functions. The instances where it actually gives you a different result are so few and far between, and so basically picky about this, I'm just going to make you do it once. So if you want to do this, basically just pick one way and do it, and if you get x, then I'm going to let you make the assumption that the other way would work as well. But here we go. And this is only for inverses. Remember earlier I talked about how it's not always the same, but if you're shooting for inverses, it will be. If it works one way, then it should work the other. Okay, so just for argument's sake, I'm going to go with f of g of x. If you think I'm full of you know what, then you can go ahead and work it out as g of f and see if you get the same thing. So again, f of g of x makes me take f, which is 4, times something or other, and then subtract 8. In this case, that something or other is the 1/4 x plus 2. Alright, so then just a little bit of distribution and combining like terms. The 4 times the 4th is just an x. 4 times 2, I think most days of the week that's 8. And then we bring down the minus 8 right there. And then of course the 2 8s cancel each other out very nicely, and we do get the x. So that's what we're looking for, but realistically this is almost like, I apologize for the use of the word here, this is almost like a proof. So really, even though I got the x is what I was shooting for, all of the work is effectively your final answer, very much like a proof is your entire body of work as the final answer. Okay, now we got another pair of functions here, and again I want to verify that they're inverses, but we have this extra little thing right here, this x greater than or equal to 0, that's going to make some people freak out a little bit, so I want to take a minute to talk about that. So basically this is part of this whole thing right here. So I've got this function f of x equals x squared, but then I've got this x greater than or equal to 0. Remember, that's a domain restriction. And I think this helps if I do at least a little sketch so you have a little visualization of what's going on here. And I've got this guy here. I get the x squared, but I want x greater than or equal to 0. So really, I just want my parabola, again at the origin, but I only want to go greater than 0, so I just want to go to the right. So vaguely, there's what my graph of this guy would look like. Again, I just care about the right side because of this, and so I leave the left side blank. So the graph of this underlined thing right here is simply that. Alright, so if I want to talk about inverses now, I'm going to do the composition again. I'm going to leave this off of the composition as I do it, because quite honestly it just gets in the way if I try to incorporate it all. So I want to do f of g of x again, and try to get just a result of x. And again, every bit of work that I do here is going to be the final answer, if you will. But here we go. Okay, so again, f is going to make me take something or other and square it. And the thing that I'm doing that to is our g of x, which in this case is a simple square root of x. And, well, not going to be a whole lot of work to do here, but of course if I square a square root, they just cancel out and I do get that x I was looking for. Alright, so there's my whole body of work. There's the x that I wanted to get. But again, mostly for this problem I just wanted to point it out that when you see one of these things, all we're doing is taking just part of the graph instead of the whole thing. Okay, now part of the reason for that inequality attached to that last function we were talking about is this thing called the horizontal line test. And, well, you might have remembered, hey, there's a vertical line test. Well, this is actually fairly related to it, but here we go. Okay, a function f has an inverse function, IFF, if and only if, I didn't misspell it, if and only if no horizontal line intersects the graph in more than one point. Okay, so we do have a little other fancy terminology that goes along with this. It's a function that passes the horizontal line test is called a one-to-one function because every x has one y and every y has only one x. So again, just to translate that into something that works, or that hopefully visually makes sense to you here. Okay, so basically f of x has an inverse function here. So I'll use function notation just to help stress that my original thing is going to have a function that is an inverse. Alright, so I need to pass the horizontal line test, so I got to make sure I draw something here that every x has a y and every y only has one x. So I'm going to do a good example here and I'll do a bad example on the right. So I'll just take something like this that looks kind of like our Barrel of Monkeys graph, and this is actually relatively a boring graph, I must admit, but there you go. So I passed the vertical line test here, so I know I have a function, and then additionally I passed the horizontal line test. So if I kind of imagine a bunch of horizontal lines, I never hit it more than once, so I know if I take the inverse of this thing, I will actually have something that does qualify as a function. Okay, so let's take a look at a non-example. So if this doesn't have an inverse function, that means I have to fail the horizontal line test. So, well, I could take something as simple as a parabola. So, again, I'm not going to bother doing fancy points or anything like that, but let's just look at a parabola right here. Of course, it is a function because it passes the vertical line test, but now suddenly, okay, that's a pretty color right there. If I take this, okay, notice that I hit this guy in two spots with my horizontal line, or at least, it's close to horizontal. Okay, so this is bad for us. So the function doesn't have an inverse function because I'm hitting it twice. We'll do something in just a minute to hopefully illustrate that a little better, but that's the basics of the test. This guy has an inverse, which is a function. This guy, yes, he has an inverse, but that inverse would not end up being a function, because again, basically what we're going to do is switch the x's and the y's when we generate an inverse. Alright, so we can find inverses graphically by, well, I'll fill in this blank in a minute, but they're going to be reflections of each other line, and you may remember that from previous things, but here we go. Let's take one we can do intuitively. If I've got f of x equals x plus 3, again, the inverse of adding 3 is subtracting 3. So just based on this, I know that my inverse is going to be x minus 3. Alright, so I want to think about what that's going to be graphically. Alright, so let's make sure we do this in two different colors, but here we go. X plus 3, so I go up 3, and then I go up 1 over 1, etc. And I should get a graph look like this. I'm going to draw a bunch of dots to help with my accuracy here, but there you go. So here's my original f of x. I get this nice 45-degree angle line. Alright, so let's switch over to red here. Alright, so I'll do this guy in red. So the inverse is going to be x minus 3. Well, if I take a look at what that is, well, down 3, but then I still go up 1 over 1, up 1 over 1. Okay, so those guys are running parallel. Hopefully you can kind of believe me if I say that these guys are not always going to end up two parallel lines, because obviously we can come up with functions that aren't lines, and therefore some kind of an inverse isn't necessarily going to be parallel. But what we got going is, if I take a look at, okay, if I want to think about making these things reflections, so I am kind of giving a little bit of a hint here. If I want to reflect, I need to be able to reflect one of these things over some other line. I'll give another hint, and have it land on the other. Well, that line is actually going to be the line y equals x. So if I kind of imagine a nice y equals x 45-degree angle here. That was supposed to be y equals x. Wow, that was sloppy. Alright, that's y equals x, trust me. That's why I get paid the big bucks. Okay, so we're looking at that. So basically that, you can imagine if I folded the paper on this green dotted line, this blue line, I'm sure you can imagine landing right on top of the red. So that's what I'm thinking graphically these guys end up playing out. Well, not just thinking, I know what I'm talking about. They're going to be reflections of each other over the line y equals x. So if I draw a graph and its inverse, I should be able to fold it and have them match up with each other that way. Alrighty, so let's take a little more complicated case that won't be quite so obvious. Alright, so if I've got f of x equals x squared minus 2, and I've got x less than or equal to 0, okay, again, this is a domain restriction, and basically, in this case, I'm saying I actually want the left half of the graph. So x squared minus 2, okay, of course, looks like a basic parabola. I'll go down 2, and then run my 1, 3, 5 kind of deal. 1, 2, 3, 4, 5. Okay, and again, I only want the left half, so I'm not going to draw any points on the right side. And again, there's my basic parabola looking guy right there. Alright, so, well, I want the inverse of this guy. So, okay, again, one of the basics of the ideas of the inverse is that you're going to take your x's and y's and swap each other. So this point of 0, negative 2, swapping that around becomes negative 2, 0. So I can plot a point there. That was supposed to be red. Let me try that again. Boom. Okay, now over here it's negative 1, negative 1. Well, switching negative 1, negative 1 still works out to be negative 1, negative 1, so there's not a big shock there. Now if I have negative 2, positive 2, that means I want positive 2, negative 2. And then over here I'm looking at negative 3, and that should be 7 up there, so I want 7. 1, 2, 3, 4, 5, 6, 7, and then down 1, 2, 3. Alright, and you can see I got the arrow tailing off that way, and this is a starting point over here, so let me do the same basic thing this way. So I'm starting my starting point and tailing off this way. Okay, again, you can kind of maybe imagine a folding line on the paper. I'll put it back in just for the sake of the visualization aspect of it. Okay, so there's my fold line. Again, hopefully you can kind of see how one would fold over and be right on top of the other. Okay, and so looking at this, hopefully you recognize that as one of those parent functions we've been dealing with. Okay, this is our square root function. Okay, but notice what's happened to it. It's kind of been flipped upside down. And it's also been shifted to the left too. So, knowing that, I should be able to write some kind of a function that includes a square root symbol that would generate this red graph right here. Okay, so again, I've got my square root, and I'll just kind of fill in what I need to fill in. A couple little hints there as far as what's going to happen. Well, first of all, it's upside down. So if it's upside down, I know I need to throw a negative sign in front of it. Okay, the other thing is, it's shifted. Instead of being right at the origin where it normally starts, it got slid left 2. So that means in here with the x, again, to slide left 2, I need to be lying, so I need to put a plus 2 in there. Okay, there was no vertical shift for the red guy, so there's no number outside. And, well, I kind of should have mentioned this earlier maybe, but it is still just down 1 over 1, down 1 over 3, down 1 over 5 as we go. So there was no vertical stretching, so I didn't need a number out here other than just the minus sign. So basically there's the inverse that way. Okay, and just as a bonus sort of thing, I'd like to do this one algebraically as well. So starting with our x squared minus 2, and again that I'll handle when the time comes. Okay, I want to do this algebraically and just generate the same thing here just to prove that it works both ways. Alright, so I'm going to cheat a little bit here. Instead of using f of x, I'm going to use y equals x squared minus 2. Well, the idea again behind an inverse is I want to take an x, replace with a y, and take the y replace with the x replace with the y, and then basically keep everything the same, and then I want to solve for my new y, because basically we're used to functions being y equals something or other that has an x in it. So here we go, we can add 2 to both sides. Get it as x plus 2 equals y squared, and then I'm going to square root both sides. I'm also going to, if you'd permit me to do so, well actually whether or not you permit me to do so, I'm going to square root both sides and now write the y on the left because he's just gotten himself by himself. So I've got y equals, I'm square rooting the entire side, so I've got this square root symbol. Hint, I left a little bit of a gap. And I can't do anything with the x plus 2 other than writing under the square root. Of course, I left the gap because whenever you square root both sides, you have a plus or minus. Well, if you think about this, hey, wait a minute, I have a plus or minus, but I only wanted the minus. Well, the reason that I'm only going to have this when I'm done with it is this guy right here. Okay, well, if I want the x less than 0, basically what that was about earlier is I wanted the left half of the graph, which is the negative half of the graph. So this means just keep the negative from your plus or minus. Of course, if this was a greater than, I would have just kept the positive from the plus or minus when we did that later on. So as a final answer now, switching back to blue, okay, I would use my inverse function notation, equals, and again, I didn't want both of these, I just wanted, because of this inequality symbol at the beginning, I just wanted the negative half of that, and then I want to keep that square root of x plus 2. And then that would be an algebraic way of finding that inverse, which notice works just as well as the graphical version. It just kind of depends on what either your personal preference is or whatever directions are asking you to do at a time. But that's how that would go. Okay, and again, just a couple quick words about the assignment. Again, it was 2 sections, so there's 2 assignments. I just kind of picked and chose a few that hopefully will get the point across pretty well. And in the section 1.8, there's a lot of finding the domain directions. Then the book is really picky about a few things here and there, and honestly, I don't really care. So ignore anything where it says find the domain out of the 1.8 assignment, and there you go. See you guys in class.